Hey everyone, Mr. Andrew here. Today we are looking at orbital diagrams. So the challenge we have today is to draw the orbital diagram for each of the elements listed below. Okay, so first element we want to draw the orbital diagram for is lithium. So here we have kind of an orbital diagram template, okay, and we want to show where the electrons are located in this atom and also what direction they're spinning. So in order to do this properly, the first thing we have to consider is what's called the Aufbau principle. Now, the Aufbau principle says that electrons in an atom try and fill up the lowest energy level first. And the reason why that is because that is what's called its ground state or its most stable state. And elements really want to be stable as they possibly can. So, first, we're looking at lithium. Lithium has 3 electrons. So we're going to first put electrons in this 1s energy level. Now, each of these boxes corresponds with a specific orbital. This first box right here is the 1s orbital. And you may remember from electron configurations that that is the one that gets filled first. So we're going to use arrows to represent the electrons here. So we have 3 electrons to place. Each of these boxes can only hold 2 electrons. So in this first box, I'm going to first put an arrow pointing up. And then after I have that one, I'm going to put an arrow pointing down. Now, the reason why these are in opposite directions is because another rule called the Pauli exclusion principle says that electrons have to be spinning in opposite directions within the same orbital. Okay? If 2 electrons are in the same orbital, they must be spinning in opposite directions. So, because of that, we use these alternating spins. Now, this first energy level, the 1s orbital, has 2 electrons. It's completely full. But since lithium started with 3 electrons, and we've used 2, we have 1 electron left. So where does that electron go? In the next lowest energy level, which is this box right here, the 2s energy level. So we're going to put an up arrow right there. And there we have it. We've used all 3 electrons. 1, 2, 3. So we have completed the orbital diagram for lithium. So let's move on to another one that's a little bit more challenging. Okay. Let's move on to the second one, nitrogen. Okay. Nitrogen is atomic number 7, which means it has 7 electrons. Okay. So again, because of the Aufbau principle, we're going to start putting electrons in the lowest energy level. Put one right there. Follow it up with a second right there. And they're spinning in opposite directions because of the Pauli exclusion principle. So now we can move on to the next energy level. 1, 2. So we've used up 4 electrons. That means we have 3 left. And these 3 electrons have to go in this 2p set of orbitals, this sublevel right here. Okay? But which boxes do we put the electrons in? We're really not sure. Or are we? Because there's a third rule. And it's called Hund's rule. And Hund's rule says 2 things. Hund's rule says, first of all, no electrons can be paired in a specific subshell, in this case the 2p subshell, until there is at least 1 electron in each of the orbitals of that shell. So we're going to start by putting 1 electron in here. And Hund's rule says we can't pair this. We have to put another electron in the next box. But which direction will it spin? Hund's rule has an answer to that too, because Hund's rule also says that if electrons are unpaired like this, they are spinning in the same direction if they're in different orbitals. So what that means is that the second electron right here, ooh, that's not what I want this color. The second electron is spinning in that direction, and the last electron is also spinning in that direction. So we've used up 1, 2, 3, 4, 5, 6, 7 electrons. That gives us 0 left over. The 1s and 2s orbitals, or energy levels, are full. In the 2p set of orbitals, there was 3 electrons left, so they're all unpaired and all going in the same direction according to Hund's rule. So with that, this is the correct orbital diagram for nitrogen. So let's look at the last one. Okay. The last one we have is sulfur. Sulfur has 16 electrons. We're going to do the same thing. Start with the 1s orbital because of the Aufbau principle. Put the 2 electrons in, put them in opposite directions. That leaves us with 14 electrons. Next lowest energy level is energy level 2, and the s orbitals are the lowest of the period 2 energy levels. So I'm going to put 2 electrons there. We now have 12 left. Next comes the 2p orbitals. We have 12 left, and there can only fit 2, 4, 6 electrons, so all these are going to be filled. Hund's rule says we do up, 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 and then down, down, down. Okay, we use 6 more electrons. Means we have 6 electrons left. Next is the 3s orbital. Up and down. That's 2 electrons used, so we have 4 left. And then last is the 3p. These can hold 6 electrons, but we've only got 4 left. So Hund's rule says up, up, up. That's 3 electrons. And the last one goes down. Okay. So if we did this correctly, 2, 4, 6, 8, 10, 12, 14, 15, 16 electrons were used. Sulfur has 16 electrons. So there is our completed orbital diagram for sulfur. Hopefully this helps you understand orbital diagrams a little bit better, and I will see you next time.